Hey, what's going on, guys? So we're going to be calculating the derivative of a function using the formal definition. So to do this, you just need to understand some basic limit notation, function notation, and then some simple algebra skills like the distributive property, factoring, and a little bit of substitution. So if you're good with all that, then it shouldn't be too bad. So let's go ahead and get into it. Okay, so here we have the formal definition of a derivative. Now, in this video, we're just going to be finding the derivative of polynomial functions. Maybe in a different video, we'll do some different types of functions, but just to keep it simple, we're going to stick with polynomial functions for this one. But given a particular function f of x, the derivative of the function, or f prime of x, is equal to the limit as h approaches 0 of the function evaluated at x plus h minus the function evaluated at x, all divided by h. And so I'll sort of explain where this comes from in another video and get to the concept of it all. But for this video, I just want to sort of work through the technique. So let's go ahead and get started. So given a particular function f of x, f prime of x, the derivative, is going to be equal to the limit as h approaches 0 of the function evaluated at x plus h. So here I need to substitute x plus h in for x here. So instead of writing x squared, I'm going to write x plus h, the quantity squared. Okay, so that is my f of x plus h right there. And then I'm going to subtract from that f of x, and here f of x is just x squared. So I can just directly substitute x squared in for f of x here. And this is going to be all over h. Okay, so now it's just a matter of algebra here. So before I can't substitute my 0 in for h yet, because then we'd have an undefined expression here. So I need to go ahead and do some algebra and see what happens. So I'm going to do the distributive property here. So x plus h, the quantity squared, is going to be x squared plus 2xh plus h squared. And then I still have my minus x squared here. And remember, this is all divided by h. And now I can simplify this numerator down. So it looks like I have an x squared and a minus x squared, so those will cancel. And now, so I'm stuck with this h in the denominator here. So that's sort of preventing me from making the substitution that I want to make. But notice how we now have a common factor of h in the numerator. So both of these terms have an h, so I'm going to go ahead and factor out that h. So when I factor out the h, I know that h times 2x will give me the 2xh. And then I know that h times h will give me the h squared. And so now we see that the h's will now cancel. The factor of h in the numerator will cancel with the factor of h in the denominator. And now that we just have 1 in the denominator here, I can now safely substitute my 0 in for h. And so I see that this limit is just equal to 2x. And so we say that f prime of x, or the derivative of f, in other words, the derivative of x squared, is 2x. Okay, so that was sort of a simple polynomial function. And now we'll move on to a bit of a tougher one here. So it's still just a polynomial function, and I still have the formal definition of the derivative up here. So I'm going to start this the same exact way. And I know that f prime of x is going to be this function evaluated at x plus h. So wherever I see an x, I need to substitute the x plus h into there. So my 4x squared is going to become 4 times quantity x plus h squared minus 2 times x plus h, the quantity x plus h. So all of this here is just this part, is just the f of x plus h. Now I need to minus f of x. So since f of x is multiple terms, I need to put that all in parentheses here. Okay? Because I'm subtracting all of f of x. So I know this whole thing is f of x. So this is my substitution. And now the reason these parentheses are important is because of this minus sign here, right? That's going to get distributed through. And remember, all of this is over h. Now I'm going to go ahead and simplify everything down. So remember from the last example, x plus h, the quantity squared, is x squared plus 2xh plus h squared. So I'll just leave those in the parentheses for now. I'll distribute my negative 2 through here. So we have minus 2x minus 2h. And then my minus sign is going to distribute through. So this will become a plus 2x. This is all over h. Okay, now I have one more layer of distribution to do here, so I'll go ahead and knock that out. That's going to be 4x squared plus 8xh plus 4h squared, and then I have the rest, minus 2x minus 2h minus 4x squared plus 2x all over h. Okay, so now I don't have any more distribution to do, so now I can just combine like terms wherever I can. So let's see what I have here. I have a positive 4x squared and I have a negative 4x squared, so I know those will cancel. Okay, I have an 8xh that doesn't have any like terms to combine with it, so I'll keep that. I have a 4h squared with no other h squared terms, so I'll keep that, the plus 4h squared. And then I have a minus 2x and a positive 2x, so those will cancel. And then I just have my minus 2h left. And just like the last one, I'm still stuck with this h in the denominator. But as you can see, I have a common factor of h in the numerator that I can factor out. So I'll factor out an h, and I'm left with 8x plus 4h, and then minus 2. And then our h's will cancel. This factor of h in the numerator will cancel with the factor of h in the denominator. And so I am left with 8x plus 4h minus 2. And now I can safely substitute my 0 in for h. And so we see that this limit is just going to be 8x minus 2. And so the derivative of 4x squared minus 2x is the polynomial linear function 8x minus 2. And with that said, it's been demonstrated.